Hi everyone, in this video we're going to look at a second example of where the leading coefficient is not equal to 1. So in this one our leading coefficient is 3, which is prime, which is nice. However, our constant term here is minus 6, and unfortunately 6 has a few factors, which means we need to look at a few different combinations to solve this problem. Let's try by listing them out. I'm going to have 1 and 3, and then we could try 1 and 6. I can also try that in a different order, 1 and 3 and 6 and 1. Now, of course, because 6 is composite, I'm going to have another couple of examples. So here we go, 1 and 3, and we can also have 2 and 3. And my last one will be where I reverse that order, so 1 and 3 and 3 and 2. Now, I don't need to reverse these ones here, of course, because that's already accounted for when I reverse the second column. So those are all of my combinations. Let's try cross-multiplying each of them. 3 and 6. And what we're trying to do is we're trying to make minus 7. So in this case, 3 and 6 aren't going to make minus 7, so that's not going to work. Let's try another one. That's 18, and that's 1. Not going to work. Even when we use negatives, it's not going to work. Here we go. That's 6 and 3. That's also not going to work. So hopefully our last one will. That makes 9 and 2. And as we can see, 9 and 2 will combine to make 7 if we put the negatives in the right place. In this case, I want to make minus 9 and positive 2 because I'm trying to make minus 7. So if this is minus 9 and positive 2, that means that this number here needs to be a minus and this number here needs to be a plus. And that's because minus 3 and positive 2 combine by multiplying to make minus 6. So I'm going to put the sign on the right-hand column of factors rather than the left-hand. Let's write it out in our factorized form now. By putting a couple of x's on there, we should be getting x minus 3 and 3x plus 2. And I did that just by putting the brackets there in our rows. That's still equal to 0. Let's just double check our solution by expanding once again. So x times 3x will give me 3x squared. X times positive 2 is plus 2x. Minus 3 times 3 is minus 9x. And minus 3 times positive 2 is, minus 6. Which is exactly the right combination that we had over here with minus 9 and positive 2. And of course, those combine in the same way to make minus 7, which means that it's correct. The last thing we're going to do is just solve this quadratic. So I'll get rid of my arrows there. And so my first solution will be where the first bracket is equal to 0, so that's just 3. My second solution this time will be where the second bracket is equal to 0, so that will actually be minus 2 over 3, or negative 0.67 to 2 dp. Let's check our solution once again in Desmos. As we can see, even though we've only graphed part of the graph, our two solutions or roots are here and here, which have x-intercepts of 3 and minus 2/3. So our solution is correct. Hopefully you are okay with factorizing and then solving the most difficult types of quadratics after watching these two videos. Thanks for watching.